Welcome back. Now we're going to decorate our gingerbread house. Making piles of similar candies makes them easier to see and choose. We can use these red and white candy canes on the roof. The pretzels look like a fence. And these green spice drops make good landscaping.
As you can see, combining similar candies is important in decorating gingerbread houses. You will also see that combining like terms is important in algebra.
In algebra, letters are often used to represent numbers. For example, here are the walls from gingerbread houses. The area of this wall is 8 times 3 equals 24 square units. The area of this wall is 4 times 11 equals 44 square units. The area of this wall is x times y, or xy square units. The letter x is a variable. It stands for any number that can be used for the length of the wall. The letter y is also a variable. It stands for any number that can be used for the height of the wall. Algebraic expressions are made up of several parts. Let's look at this expression. This expression has 4 terms. Some terms include variables. Terms without variables are called constant terms.
The coefficients are the numeric parts of the terms.
Your answer is correct.
In the expression 5y cubed plus y minus 4/3 xy minus 2, the terms are 5y cubed, y, negative 4/3 xy, and negative 2. The coefficients are the numeric parts of the terms. These are 5, 1, negative 4/3, and negative 2. Note that the coefficient 1 is generally not written in an expression.
Let's see how to identify like terms, terms that have the same variables with the same exponents. Here are the x squared terms. They are like terms. Here are the x terms. They are like terms. Here are the y terms. They are like terms. And here are the constant terms. They are like terms. Your answer is correct. Like terms have the same variables with the same exponents. For example, 4/3 x squared and negative 1/3 x squared. Both terms are x squared terms. The terms negative 2xz and 4zx are like terms because both have the same variables, x and z, and the same exponents. We know that 5 boxes plus 3 boxes equals 8 boxes. And 5 cookies plus 3 cookies equals 8 cookies. Similarly, in algebra, we can combine like terms by adding them. 5x plus 3x equals 8x. And 5x squared y plus 3x squared y equals 8x squared y. We know that 5 boxes minus 3 boxes equals 2 boxes. And 5 cookies minus 3 cookies equals 2 cookies. Similarly, in algebra we can combine like terms by subtracting them. 5x minus 3x equals 2x. And 5x squared y minus 3x squared y equals 2x squared y. Combining like terms is justified by the distributive property. We can simplify this expression by combining like terms. Identify like terms. Use the commutative property to move the like terms next to each other. Now combine like terms. So 5x minus 4y squared plus 3 minus 2y squared minus 3x minus 2 equals 2x minus 6y squared plus 1. Your answer is correct. We combine like terms to simplify the expression. Combining like terms is like adding objects. If we add 9 books plus 4 books, we have 13 books. Similarly, if we add 4x plus 2x, we have 6x. If we add 3xy plus xy, which is the same as 1xy, we have 4xy. Sometimes an expression contains parentheses. To simplify the expression, we use the distributive property to remove the parentheses. Then we combine like terms as before. Simplify 4 times the quantity x minus 3 minus 2 times the quantity x plus 7. To remove parentheses, distribute. Move like terms next to each other. Combine like terms. So 4 times the quantity x minus 3 minus 2 times the quantity x plus 7 equals 2x minus 26.
Here's another example of an expression that contains parentheses. To simplify, we use the distributive property 2 times to remove the 2 sets of parentheses.
To remove parentheses, distribute. Move like terms next to each other. Combine like terms. Your answer is correct.
Here's how to distribute the 5. Here's how to distribute the 2. Here's how to combine like terms.
To evaluate an expression, we replace the variables with numbers. Then we do the indicated operations. The result is a number. For example, evaluate 2x minus 3y plus 77 when x equals 5 and y equals 9. Replace x. Replace y. Calculate. When x equals 5 and y equals 9, 2x minus 3y plus 77 equals 60. As another example, let's evaluate the same expression using other values for x and y. Replace x. Replace y. Calculate. When x equals 1 and y equals negative 6, 2x minus 3y plus 77 equals 97.
In our gingerbread house, the area of the wall was xy square inches. If we cut out and remove a door with area 12 square inches,
then the area of the wall is xy minus 12 square inches. If we also cut out and remove a window with an area z squared square inches, then the area of the wall is xy minus 12 minus z squared square inches. Your answer is correct. Replace x with 5, y with 8, and z with 2. So the area of the wall is 24 square inches. Here is a summary of simplifying expressions. Expressions are made up of several parts: terms, variables, coefficients, constant terms. We can simplify expressions by combining like terms. Here we use the distributive and commutative properties. We can evaluate expressions by replacing variables with numbers, then calculating. You may want to take notes in your journal. In this Explain, you learned about simplifying expressions. A summary of this concept is found on the following screen. Here is a summary of simplifying expressions. Expressions are made up of several parts: terms, variables, coefficients, constant terms. We can simplify expressions by combining like terms. Here we use the distributive and commutative properties. We can evaluate expressions by replacing variables with numbers, then calculating. You may want to take notes in your journal.